friends! Welcome to Coding Garden with CJ. Welcome to Code Wars Code Katas episode 36. Look at all those wonderful drops. Welcome to the show. If you're new to the show, you can visit github.com/codinggarden/code-katas. As I mentioned, this is episode 36. All the code for the past episodes are up on GitHub. All the code I'm going to write today will be on GitHub as well. If you've never heard of Code Wars, it's a website where you can solve coding problems. And that's what we're going to do today. And in an hour and a half, the advent of code opens up like the latest challenge, so I'm gonna do that, and I have a timer set, so we're gonna do that as well. We're gonna do lots of coding problems. Hello Harsh, welcome to the stream. Hello Ran, hello Leon, hello Josh, hello Alka. Leon is asking, anyone know how to structure an RBAC app? I've literally never heard of RBAC. RBAC? Role-based access control. Oh yeah, I've done it. I didn't call it RBAC, but yeah, I'm sure there's a lot of different ways to implement it. I implemented it from scratch in an Express app where we had database tables that stored the different types of roles. We had a join table for users where they could have many roles. Every single route was restricted to a specific permissions. If you're writing it with node.js, check out JWT permissions or something like that. Let's look on npm. Yeah, there's Express JWT permissions and Express JWT authorization. There might be some others, but basically what these allow you to do is put permissions in a JSON web token, and then they have a middleware which can check against those permissions. So you can check out those. And JWT authorization is very similar. But yeah. Hello, Andrew. Welcome. Harsh is saying, I was just creating a starter kit with Parcel. Cool. Yeah. Starter kits are fun. Andrew has been doing code katas with Morning Sage. That's fun. Together? Are you like pairing on it? Hello, Bubba Gump. Welcome to the stream. Hello, Jorge. I'm doing good. Yeah, it's a good day. Hello, Ed. It's 5:30, so you won't stay for long. Just finished making some progress on the Seedling School project. That's great. But get some rest. Or I guess 5:30 a.m. means you're getting up for the day. But yeah, welcome. Andrew says we're internet friends. Well, that's cool. Awesome. So I think I'm going to start off with a 7Q. Maybe I'll start off with a 6Q. What do you think? Let me know in the chat right now. 7Q or 6Q? Where should I start? And hello, Jonathan. Welcome to the stream. Oh, going to sleep this early? Okay. Well, that's good. Good morning, Ashwin. Hello, Carlos. Hello, this is Tony. What do you all think? 7Q or 6Q? 7Q is usually really easy, and we can solve it in multiple ways, but we've only got an hour and a half. So, but before we have to do the Advent of Code challenge. So we really probably can only get 1.5 done. Rand says 7, Josh says 6. Shifronim says 7. Andrew says 6. It's a tie right now. We got 2 6s and 2 7s. Yes. Hello, Etz. Welcome to the stream. Yes, you're here early, Carlos. We haven't even started coding yet. 6 and 7. All right, we'll start with the 7. We'll start with the 7 for sure. And hopefully we'll get it done fairly quickly, because we may run into a situation where I won't do another one because we're going to wait until the Advent of Code gets released. But yeah, go harder. Advent of Code is a little hard. They're pretty difficult. Hello, Vladimir. All right, we're going to go for a 7Q. There's Anagram Detection, sort arrays, power of 2, number of occurrences, find the middle element, most digits. Let's see. We're gonna go with 7, because hopefully I can finish a 7 and maybe like one solution with the 6, not multiple solutions of a 6. But yeah, yeah, just blast through a 7. We'll do it. An anagram is the result of rearranging the letters of a word to reproduce a new word. Anagrams are case insensitive. Complete the function to return true if the 2 arguments given are anagrams of each other. Cool. Yeah, slip in a quick 1Q. Just a simple sorting usage. Create a function that returns the elements of an input array in the sorted manner. I'm not going to do that one because I think I implemented quicksort a few streams ago. So yeah. Power of 2. Complete the function power of 2. A power of 2 is a number in the form 2 to the n where n is an integer. The result of an exponentiation with the number 2 as the base and integer n as the exponent. You may assume the input is always valid. Huh. Well, 2 to the n equals this, and then we solve for n, and if it has a solution, then we return true. And there's something to do with log there, right? We could invert that to take the log of this to see if we get a whole number. I think that's how that works. Hello, totally sane. Yes, Katas are back. Motivation maxed out wants to give me a compliment. I learned Node in the past with your Craigslist scraper, but I forgot since I delved into Python. But now I'm back and I'm watching the scraper again. Oh, cool. Cool. Yeah, that was always a fun one. Write a function that returns the number of occurrences of an element in an array. Easy enough. Find the middle element. Create a function that, when provided with the triplet, returns the index of the numerical element that lies between the other two elements. Interesting. That's a interesting one. Find the number with the most digits. If two numbers in the argument array have the same number of digits, return the first one in the array. Okay, we're going to do a quick poll. And then we will solve some katas. Let's take a quick stretch. Which 7Q? All right. Anagram detection. Power of 2. Number of occurrences. Oh, it wants us to write a prototype method. That's weird. Has anyone ever unzipped a file from a buffer in node.js? I feel like I have, but I don't remember why or when. Finding the middle element. If you can find a probably like a stream-based zip library for Node.js, that might be your best bet. Because I'm guessing you've already read the file in. It's either a stream or it already is a buffer array, and then you can just pass it to the zipper thingy. Find the middle element. And the last one is most digits. All right, here is your poll. Vote for Katas. That's funny. I read it as a buffer from a CDN. Oh, interesting. Jeebus. Vote. Let's look at the results. See, there are no votes. I put that many links and there's still no votes. Let's catch up. And then while we're waiting, I might search on npm because I'm pretty sure I've done some unzipping with. You know what? If you're on a Linux-based system, you could just pipe the output to unzip. So yeah. I don't know what this means. This is Tony. I guess we'll translate it. Good morning. Good morning. See you later, Ed. Thanks for tuning in. Yes, katas have returned. Drink time. Windows and Linux. Maybe you can find like a 7-zip package on like a 7-zip binary wrapper on npm. Jeebus. Let's see what this says. Very hard, isn't it? I guess so. zlib. It's very tight. Vote now. The link is in the chat. Vote now. zlib. Wow, Andrew Lane with the 99.54. Great drops. Great drops. And it looks like Warhawk has just hit him to the target. Not quite in the center, but it was a good battle. Unzip cross-platform streaming API compatible with F-Streams and FS-Readstream. This was published 5 years ago, though. This one was published 3 months ago. Oh, your bot drops every 30 seconds. Well, your bot's doing a great job. This is an active fork and drop-in replacement of the node unzip. Yeah, so read a stream and then pipe it into unzipper.extract. So if you already have a stream, you can just pipe it in. The cooldown is 30 seconds instead of 90 seconds. Well, it should be anyways. Vote for zlib. I'm not gonna implement it. I was just curious because Andrew mentioned they were trying to do some unzipping with Node. You can only get on the leaderboard once, so your highest score will be the only thing that shows on the leaderboard. It's still stored in the database. But yeah. All right, we're gonna go for it. Anagram has 6 votes. Let's do it. Let's close these others. Oh, it's built into Node? What? I didn't know that. What? Wow. Using gsip and deflate and inflate. That's super interesting. Okay. Great. All right, we're going to do anagram detection. This is a 7Q. We're going to bring it down locally. Hello, Bob. Welcome to the stream. Yeah, the bumping aspect is very interesting. It makes the game much more interesting. Yeah. Hello, Sukchit. Welcome to the stream. Yeah. The word is unfair. Get it right. No, it's great. Because if everybody could just land on the target so easily. But look, it's totally sane. You have a 99.21 on the leaderboard. I don't know what you're complaining about. Oh, wow. Josh used it once to download a YouTube video, zip it, and then upload it to a bucket. Wow. Oh, I see. You were eluded. That's still a pretty, that's a very high score. The highest possible score is 100. Nope, this is a cherry flavored bubbly. Carbonated water. It actually tastes a little bit like Dr. Pepper because it's cherry flavored, which is why I like it. All right, let's write this function. So we have our function called isAnagram, and then we have a few tests. And we're going to change these just to be console logs. Let's do it like that. We're going to rewrite this as a function like that. Let's see. we go. Cool. I'm going to start up Quokka. It should have undefined because our function does nothing. Cool. All right. I'll catch up on the chat and then we'll write some code. Write some code. Did you get bumped again? Totally sane. Again with the bump. Bob says Dr. Pepper is not cherry flavored. It's Dr. Pepper flavored. Don't they have like a secret recipe with like 23 flavors or something like that? I don't know. Tony is asking what I prefer for programming, Ubuntu or Kali or something else. I prefer to use a Mac. That's what I'm using right now. If I couldn't use a Mac, I'd probably use Ubuntu just because it's what I'm used to. And thanks for the follow, Turlim Bom Bom. Welcome to the stream. All right, I'm gonna turn off the drop game while I code. Is Foufet even a word? I don't know of it as a word. Let's see. It looks like Andrew's gonna land in the center, so we're gonna turn it off. And we won't know. We won't know where they land until we turn it back on later. Totally Sane says, I installed VS Code and Python on a Mac, and my Windows PC are ready to do the some stuff when I get free time. Nice. No, it pauses the execution of that JavaScript engine running in that browser source. So when I turn it back on, it'll take off right where it left off. Don't worry. Don't worry. Dr. Pepper is all the drinks combined. It was probably your bot that dropped anyways, huh, Andrew? I don't know. Okay, so we need to detect if one thing is an anagram of the other thing. And thanks for the follow, Candy Cane 20. So I think the way that I'm going to do this is I'm going to count up the number of occurrences of each letter in each word. And if the number of occurrences of each letter in each word match, we have an anagram, right? Right? So I'm just going to write a simple function that iterates. Actually, I am going to create a function. We're going to call it like count letters. And that takes in some input. And then we're going to return an object with the count of letters. But we're going to do the same thing for both of the inputs. So that's the plan here. So to count the letters, we need a place to store the counts. And for this, I'm just going to use an object. So we're going to end up having an object where it'll have like F2 because there's two Fs, 0, 1 because there's 1, 0, E2 because there's 2 E's, and T1 because there's 1, 2. So for this word, that's what we're going to see. And then for toffee, it actually has it'll result in the same number of counts. So we're going to generate this object that has the counts of all the letters. It could be an odd number of letters and still an anagram. Yes, that's fine. But once we build up this object, we'll know exactly how many of each letter, and both strings should have the same number of each letter. So a place to store them, that's going to be like an object. We'll then iterate over the letters of the, what if it's the same word? Then we could have an early condition. We could say, if the two things are equal to each other, then just return true, because we automatically know that it is an anagram. Iterate over the letters of the word. And for each letter, we'll, if the letter is not in the counts object, add it with count 0, and then we'll say increment the count in the counts object, the count of the current letter in the counts object, and then return counts object. Cool. So this is what we'll do first. So we'll say counts. This is going to be an object, like so. Iterate over the letters of the word. So I mean, yeah, I'm going to solve this with a for loop. We could use a reduce. We could get fancy with it. Checking length is an early back out too. Yeah, so if the two strings are not the... Let me add these things that people mentioned. So if length is not the same, instant false. If the words are exactly equal, instant true. Cool. Okay, so iterate over the letters of the word. Okay, we're gonna use a for loop, but this is like a classic reduce, but we're gonna use a for loop. So we're gonna say while I is less than input.length, and then we're gonna get each individual letter from the input, and then we do this goodness here. So if the letter is not in the counts object, so we'll say if counts at letter, if it's not there, then we add it with count 0. So I'll say counts at that letter equals 0. And then we increment the count of the current letter in the counts object. So we will do that plus plus, like so. So what this does is whatever that letter is, it's going to check to see if it's a property on this object. If it's not, it'll add it and set it to 0, and then we will increment it. If it was already there, then we just go ahead and increment it. One thing we'll do is it's case insensitive, so we probably want to set this to lowercase before we start adding the properties here. We could say input equals input dot to lowercase. So before we do everything else, it's already to lowercase. Cool. Let's take a quick stretch. And I'll say hello to everyone that showed up. Hello, Ashtu from Australia. Hello, Damien from Sweden. This is a 7Q. Yeah, and hello, Marco. Could be odd number of letters and still an anagram. Yeah, I think we covered that. Do people develop on Debian? I've been using a lot lately. Yeah, absolutely. I mean, Ubuntu is based off of Debian. Cool. Okay, and then at this point, we just return counts. So let's test. So we've broken the problem down into like a sub problem. Let's test this function to see if it works. So if we just log count letters with Apple, we see that we get an object where the key A has 1, P has 2, L has 1, E has 1. And if we do Apple, it's case insensitive, so now there are 2 A's, 4 P's, 2 L's, 2 E's. So we definitely just want input.length, because when I is input.length minus 1, that will be the last letter, and then it will break. And Jorge Pasco just pledged on Patreon. Thank you so much. Huge thanks. At some point, I want to list all the patrons on my screen. Not today, but I want to build something that will like show all their names. But thank you, much appreciated. Cool. So this seems to be working. So that's great. Now we can work on the actual is anagram. So if the words are exactly equal, instant true. And now we can use the count letters. So we will count the letters of the test, count the letters of original. So test and original are the two things that we're comparing if they are anagrams of each other. I want to call this like first and second. I don't like the names test and original, because they're literally two strings that we're going to compare. So we will count letters in first, store it in a variable, count letters in second, store it in a variable, store in a variable. And now we have two objects with the counts of the letters, and we need to make sure that those two objects basically have all the same properties and the same number of counts for all of those properties. Cool. I mean, we actually could do like JSON.stringify and then compare the two. We're not going to do that though. We're going to say we're going to iterate over the keys and make sure that they all match. So first thing I'll do is check if both counts have the same number of keys, because if one has more, then that means it has extra letters that the other one doesn't have. So if not, instant false. So if they have a different number of keys, then we instantly return false because we know that there's no point in checking the objects. If they do have the same number of keys, then we need to iterate over the keys and make sure that the counts are all equal. So we'll say iterate over the keys of the first counts object. If the second counts object does not have the same count for the current key, return false. So the moment we find that the two don't match, we're going to return false. And then overall, if nothing returned false, then we'll return true lastly. Cool. And there we go. Andrew's got a one-liner, but let's write it out. So we'll do these early checks. So if first.length does not equal second.length, then we're just going to return false. Easy enough. If first is equal to second, then we'll return true, because there's no point in doing anything else, because if they're the same string, then they're obviously anagrams of each other. Cool. So now count the letters in the first and store it in a variable. So I'll say first counts will be count letters of first, and then we'll do the same thing, but with second. Second counts. Cool. Oh, this is only count letters. I see. Yeah. So we could write this as a one-liner reduce, absolutely. But for now, that's what we have. Okay, so we've counted both of the letters, and for now, I'm going to comment all of these out, and I will show you what we have. So if we log first counts, and if we log second counts, we can see we have two objects. Now, the order of the keys are different, right? So in this first one, we have F0ET, and in the second one, we have T0FE. Technically, they have the same values, but based on when we put those keys into the object, they're in a different order. But that's what we ended up with. Now we want to make sure that the values for all the properties are the same. So T is 1 in here, and T is 1 in there. E is 2 in here, and E is 2 in there. F is 2 in here, and F is 2 in there. So basically, that's what we need to do next, is compare and make sure that they're all the same. But before we do that, check if both counts have the same number of keys. If not, instant false. I'm going to do this. I'm going to say first count keys is first count object.keys of first counts. So object.keys will give us all of the properties of the object. So like if we log first count keys, we see these are the keys. So that's great. And the reason I'm storing it in a variable is because I need to iterate over the keys here. So I went ahead and stored it in a variable so that we don't have to call .keys again. So let's do this. Check if both counts have the same number of keys. So we'll say if first count keys .length is not equal to object.keys of second counts, then we instantly return false. Yeah, something weird happened with my formatting. So if the keys are not, if they have a different number of keys, then that means one of the words had extra letters in it. So if that's the case, we return false. Otherwise, we need to check every single one to make sure it has the same counts. So we've already stored first count keys in a variable, so we can use this to iterate. So we'll have a for loop, and we'll say I, while I is less than first count keys dot length. And we'll say letter is going to be first count keys at I. And we want to do this check. So if the second counts object does not have the same count for the current key. So what we want to say is if first count keys, if first counts at letter does not equal second count at letter, return false. So if there's a letter in the first word that's not in the second word, it will return false. Or if there's a letter in the first word that doesn't have the same count as a letter in the second word, it will return false. Otherwise, we make it to the end of the string, and then we return true, like so. Okay. Oh, and I forgot to do .length right here. Because the check we want to do is if they have a different number of keys, then they have different number of letters, and it's instantly false. Otherwise, we need to check every single one, and we can see that we get true. On this one, we get true. That one, we get true. That one, we get false. We get false, and we get false. We have a working solution. But now we can clean it up, because there's a lot going on here. We could be way less verbose. I'm gonna catch up on the chat, and then we'll write it in a few more ways. Hello, Joundi. Welcome to the stream. Yeah, we covered what if it's the same word. Hello, Damien from Sweden. Yeah. Okay, so this is Andrew's one-liner for count letters. Oh. We'll go with this one. This one has like weird escape characters. Cool. Good morning, Benjamin. Welcome. Ashwin is saying it would be awesome if you could also explain time and space complexities. I will try. So I know that this solution is order in because I don't have any nested loops. I'm only doing I have quite a few iterations, but it's all single iterations and no nested loops. So it's a big O of n. In terms of space complexity, we'll look at that. Oh yeah, hello Ioli. It's called Quokka. If you go to quokkajs.com, it's pretty sweet. It yeah, it runs your code inside of VS Code. Yep. Friendly reminder to hydrate. Can we order them alphabetically and then compare the two? Yes, but ordering them alphabetically is a sort. And sorting algorithms have best case in log n complexity. Whereas my solution has big O of n. So mine is linear versus log would be best case, but worst case, your sorting algorithm is like n squared. Yeah. Hello, Cheyenne. And hello, Brandon. Welcome to the stream. Okay, so this works. Beautiful. I'm going to write my own one-liner of this function here. Basically, this function, which is creating that object of letter counts, we can write this as a reduce. So let's do that here. And what we can do is we'll return input.split. So we'll turn that string into an array so we can reduce it. One thing we could also do is spread the string into an array. I think that's what Andrew did. So if I do ... the string, that takes all of its letters and puts it into an array. So we now have access to reduce. So that's great. And then we're going to get the counts object and each individual letter. The thing we're accumulating is an object. And on each iteration, we need to return the counts. Cool. And on each iteration, we need to increment the count of the given letter. So we can say counts at letter equals counts at letter or 0. So this one line of code here is doing the same thing as this if statement here. So this if statement says, if counts at letter doesn't exist, set counts at letter to 0. And then what I've done on this line of code is saying, counts at letter either equals itself. So if it's already in there, leave it the way it is. Otherwise, add it and set it to 0. So this one line is doing the same thing as this if statement. And then we increment the counts. So we'll say counts at letter plus plus. Cool. And so this function is now is the one that's being called, and it should still work. So true, true, false, true. Oh no, we did something wrong. I'm just gonna log each letter. Oh, we need to lowercase it. Yeah, so let's say input.to lowercase, and then we reduce it, and that should be good. Yeah, true, 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 false, 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 false. Cool. So this is a nice little this function right here does exactly the same thing as this function, except it uses a reduce instead of a for loop. And now that we have it in this nice little reduce, we can turn it into a one-liner. So for that, we can use the comma operator. So we can basically turn this one line of code, or these 3 lines of code, into a single line of code. And what we'll do is we will first want to do this. Then we want to do this. We'll use a comma. And ultimately, we want to return counts. So we're going to say return like this. And this should work. So the comma operator will execute multiple statements. So it'll execute each of these, and then the last one will be the thing that the expression evaluates to. So this ultimately will return the object counts. And this should still work, and it still does. Cool. And oh, I see what Andrew's doing. Yeah. So and that would actually shorten this to make it only a single. Instead of having 3 statements in the comma separation, you can have just one. Let's take a quick stretch, and then we'll show that. Yeah, that's another way to do it, Josh. This is like, this gets extremely confusing though, because what this does is this accesses it and then increments it. But no, you might run into an issue here, because if the accessor is if it's not in there, then you're going to get undefined. Undefined plus plus is nan. And is nan a falsy value? Maybe? It's too confusing for me. It might work, but it's too confusing. But let's also write this the way that Andrew just mentioned it. So we can say counts at letter or 0 plus 1. And then we can get rid of all this extra stuff. Nan is falsy. Okay, so technically that would work then. And with Andrew's suggestion, that still works. Cool. So we basically shortened, instead of doing setting the initial value or getting the initial value and then incrementing it, that does it. Cool. And then now that we have this, we can really turn it into a one-liner. So because this is an arrow function, we can remove the return statement and remove that there. And then if we zoom out a little bit, if it's all on one line. So count letters does that. So that's great. And it still works. Cool. I'm going to catch up on the chat because we have some follows. Thanks for the follow, Mar598, and thanks for the follow, Windex Gaming. Welcome to the stream. Speaking of Windex, I need to clean my mirror upstairs. I thought of that today. I should get some glass cleaner. Mar598 says, great stream, not really on topic, but it would be better to build a Swift app that can then take into a web app, or write a web app in JavaScript and make it into an app with a JS variant. It really depends. You might look into Flutter. I know that's not what you asked, but Flutter has so it's by Google. You write your apps in Dart, and they're cross-platform, and they'll run on Android and iOS. But they also have Flutter for Web, which basically allows you to use the same code base for your cross-platform mobile app and your web app. Yeah, the web is currently in tech preview. It's not like completely production ready yet, but this is definitely the way of the future. So yeah, I'll save your question for later. Maybe we'll be able to get into it a little bit more. Thanks, Mar. Appreciate it. Can you remove that line? And yeah, so let's show it working with this. And really, this takes a lot of there's high mental load whenever we write it like this. Yeah, that's a great point, Freebly. I make that point all the time. And basically, don't ever do this in your code base. It's fun to see it written all these different ways, but like I just mentioned, this is like high cognitive load. So if a programmer comes across this line, first we need to unpack this. So this says access the value in the object at letter. Whatever that is, we're going to increment it. If this results in undefined incremented is nan. Nan is falsy, so then we set that value to 1. If this, if it wasn't, then we increment it, and the resulting value gets stored back in itself. So yeah. But yeah, Freebly says, don't forget it's very likely that coworkers will need to work on your code at some point, and the most concise isn't always the best. I like the first reduce. Me too. Yeah, so if I had to choose one, I would go with this. I prefer doing it this way. Like I said, having the nested plus plus is a little weird to me, and even having like these is a little weird to me, because this like access it, if it's undefined we have 0 and then add 1 to it. But I would write it this way. There's a high mental load is my slogan for coding. That's the way to think about it, though. If another programmer came across this code, could they just look at it and instantly know what, for the most part, what that code is doing, or do they have to like take a step, take a pause, and actually break it down? And if they do, then that's not good. Yeah. So there's that, and then we'll clean up this is anagram function too. Nan plus 1 equals nan. So that would break. Did it break? This wouldn't be nan though. This one would be undefined. So this would be undefined or 0. So it becomes 0. Or does it? That's weird because you have or and they're both falsy. I don't know. It seems to work. Oh, replying to Candy Cane. I see. Cool. JS is so good. It's cool. The fact that there's so many ways to do it is maybe not that good. Cool. I can also spread the count so I don't need the comma. Oh. That's true. Yeah, let's do that. That's an interesting way to do it. Which one? Let's go with this one. Cool. So ultimately, this reduce needs to return an object. So we can spread all of the existing values in counts, and then we want to override at that given letter with this logic here. Like so. Oh, we need that. And we're going to move this one down, so this is the function that actually runs. But this is, let's see, does it work? Yeah, it still works. So, spreading the object is like object.assign. It basically takes all of the properties and puts it into this new object. And then this is computed properties. So take the value of letter and let's, well, yeah, so the value of letter, we want to change that property to either be itself plus 1 or 0 plus 1. So that works too. So many ways. High mental load. I should make a t-shirt with that on it. There's a high mental load. Yeah. No, you, Morning Sage. Write code like your coworker is an axe murderer. That's great, right? You don't want to be axe murdered in the middle of the night, so write code that they like. And thanks for the follow, Freebly. And thanks for the follow, Ashtu. Nan or 0 equals 0. Yeah, so it basically resolves to the last value, which is weird, though, because they're both falsy, right? I mean, if you would think that this resolves to a Boolean, then this would resolve to false, because they're both falsy, but the OR operator works in mysterious ways. Hello, coding room. Welcome. Okay, so we have that function. Great. Now let's make isAnagram a little nicer. Ben is asking, how can you know which is the best way to solve a problem? I think at first, if you're just getting started with solving coding problems like this, whatever makes the most sense to you. So someone earlier asked about time and space complexity. Once you know enough to, that's not working. Oh well, I'm not worried about it. I'll add a comment. This might not work. um, but once you've gotten good enough at solving problems, you can learn about this thing called Big O, which is basically how you can analyze the runtime of an algorithm. And so, yeah, so as a beginner, if it works, that's great. As you start to write more and more code, and maybe you're working on larger code bases or you're working with other people, you want to make sure that your code is performant. And senior, whichever way works. Honestly, yeah. I've actually gotten pretty jaded lately looking at other people's code in the professional world because a lot of people just don't care. So I think as long as you're trying to make your code better, that's all we can ask for. That's really all we can ask for. But efficiency is one way of looking at if it's the best way to solve a problem. But even though something's efficient, it may not be very clear. So like Weebly, I think that was your name, right? Weebly? Freebly, sorry. Like Freebly mentioned, just because it's concise doesn't mean it's good. And maybe if it's more performant, it's probably harder to understand. So a less performant solution is maybe okay. The answer is it varies and it depends. Even if it's something that looks messy, I look at so much messy code. It's really depressing. All right, let's clean up this isAnagram function. Here, I'm gonna just copy and paste it, and then we're gonna gradually clean things up as we go. So this is fine. We have a check, or early checks to decide whether or not it's an anagram. I do like storing these in variables, so that's great. This is a little interesting that I'm not storing the second one, the object keys here in a variable, and the reason is I don't need it because whenever we're doing the checking, we're just iterating over the first one's keys. So one thing I can do is I can turn this for loop into an every. So what I can say is if every key in first counts has the same count in second counts, then it returns true. Otherwise, it returns false. So we're going to return first count keys dot every, and that's going to give us each individual letter. And then we basically just want to do this. Return first counts at letter is equal to second counts at letter. Done. Because if it's not, then it's instantly false. So every is a higher order method on the array where if every invocation of this function returns true, then this whole thing will return true. But if any of them return false, the whole thing will return false. So I like that. That's a nice way to clean this up. It's just basically doing exactly the same thing because the moment it finds something where they don't equal, it's going to immediately return false. That's the cool thing about every, and then there's also sum, which is built into arrays. They will exit early if something returns false, or sum will exit early if something returns true. Every will exit early if something returns false, which is not, you can't say that for reduce or for each or map. Those or filter, those are going to always iterate to the end. Every will exit early. So cool. All right, what are we going to submit? I am going to use this one as my count letters function. And this last isAnagram that I just set up. We're going to submit that one. Sample test. Attempt. We did it! Yay! All right, how much time till Advent of Code starts? 39 minutes. We probably have time to do one 6Q. So let's get that going. Wait, did I accidentally close the tab? Oh, okay. Sorry. We'll look at some other people's solutions before we moved on to that. But yeah, we are going to do a 6Q. Candy Cane is asking, what's the worst code base you've ever seen? Was it in JavaScript, Node, or C#? I've been working in JavaScript for the past like 5 years, so most of the code I've looked at recently was in JavaScript. But I've seen a lot of bad C# code too, because I used to do C#. There's bad code everywhere. I'll just say that there's bad code everywhere. Time for a quick 1Q. No thanks. Hello, Simon. Welcome. Let's look at some other people's solutions. Cool. So someone in the chat earlier mentioned, like, why don't you just sort it and compare it? It's totally a valid option. And Philtor and Lala, thanks for the raid. Thanks so much. We are solving Code Wars Code Katas. We just solved Anagram Detection. So we wrote a function that determines if two strings are anagrams of each other. Hello. And in 37 minutes, we're going to attempt Advent of Code, because that's when it gets released. So right now, we're looking for another one. What were you working on? Are you playing games? Or, yeah, what do you do on your channel? Welcome. But someone in the chat mentioned earlier, why don't you just sort both strings and then compare them? Because if they're sorted and they both equal, then we know that it's an anagram. Oh, you were coding. Sweet. What were you building? Or working on? So yeah, let's take a quick stretch. Oh, and someone did ask me to analyze the time and space complexity. Let's just do that really quick of my solution, so we can talk about this. So we're gonna look at this one. So count letters is big O of n. So we can look at the count letters function. And my original solution is just a for loop, right? Count letters will have to iterate over every single letter in the string. So we say that this function is linear, big O of n. And that's because we have usually if you see a for loop and it goes from 0 to the length of the input, this function is probably big O of n. Technically though, I just caught it, this is actually 2n, because 2 lowercase would have to iterate over each letter to make sure that each one is lowercase. So this is technically big O of n, and then this is big O of n, so n plus n is 2n, but that actually simplifies to big O of n. It's linear. And even our reduce has the same complexity. Though this actually seems to have 3 iterations, because we have 1 iteration to send it to lowercase, another iteration to turn it into an array. So that's 2 iterations, and then a 3rd iteration to reduce it and iterate over each letter. So count letters has big O of n. In terms of space complexity, we are... Actually, I don't really know how to calculate that. Does that work as big O of n as well? I mean, technically, we're creating an object that has all of the unique letters in the input. So it's kind of like big O of m, not n? I don't know. I don't know about space complexity. But I guess the way to think about space complexity is like in this solution, we're creating 2 objects, right? 2 objects which are the counts of all the letters. Each of these individually are big O of n. So technically, the is anagram is big O of 2n. Object.keys has to iterate over the object to find all of the keys, so that's big O of n. We have another big O of n there. This is basically like n plus n plus n plus n, which is still linear. And then this is also, this is like big O of m, because the number of unique characters isn't the same as the input length. So I would call this one big O of n plus m, because you potentially have 2 different inputs of different length, but it's still linear. Cool. All right. That's enough of that. But if we look at this person's solution, they send it to lowercase, so that's 1 iteration. It's at least big O of n. They split it into an array. That's another iteration, so that's 2n. And then they sort it. Now, we don't know what sorting algorithm this is. Oh, yeah. Let me turn the drops on. Are you all ready for this? Andrew's going to be like right here. Let's see where he lands. That's great. But yeah, I mean, we could determine what Docker engine they are running to actually run the JavaScript to determine what sorting algorithm was used, but sorting algorithms usually have like a best case of in log in. In worst case, in squared. So that's why I didn't exactly want to do the sorting method, because it's definitely worse than just iterating over the thing. And then we have another join here. So this would be big O of 3n plus in log in. So maybe this is in log in. It may also be n squared. So this has a higher complexity. Basically, we have to do that twice because we do it on both the input strings. Yeah, so they did the sorting. They did the sorting. Everybody's doing the sorting. Weird. I don't like any of those solutions. All right, let's catch up on the chat. Josh is saying the worst code I've seen is in C#, a research project I took over. I mean, because I've mainly been working in JavaScript lately, it's probably been a JavaScript code base that was the worst. Yeah. Working on a Discord bot. Very new to programming. I've been working on a Discord bot using Discord.js and Comfy Discord. Sweet. Yeah, I built a Discord bot a while back on my channel. Because my Discord, the bot's a little messed up right now. It kind of like crashes all the time. But for my Discord, when you join, the bot automatically puts you in, we call it germinating, where you're not allowed to send messages in any of the channels. You then have to emoji react to the code of conduct and send a 40-character introduction in the introductions channel. And once you've done both of those things, you get the seedling role, which gives you access to the rest of the channels. But I built that probably over a year ago, so that was pretty fun. But I use Discord.js. Oh, cool. Yeah. Yeah, and so like I just found InstaFluff's channel probably like a month and a half or 2 months ago, and when I joined his Discord, they have the role selector in the main channel, which is pretty cool. But yeah, my channel mainly just works off of the seedling role, which is what the majority of people have, and then there's other roles for like patrons and stuff like that. Advent of Code. Yeah, so Advent of Code are daily coding challenges leading up to Christmas. So it started on December 1st. Today is, well, technically today is December 4th, but they released the challenge in 30 minutes because people are in various time zones. Yeah. Let's see. My worst code was in Java, converting integer to letters and converting letters as it sounds in English to an integer. Interesting. Yeah. Hello, Pranjal. Welcome. There's, oh no, there's another raid. What's up, Noise Brew? Welcome to the stream. Yeah, welcome. Welcome. Did you have a good stream? What were you working on? Were you coding? We out here. Yeah, it is 10, no, is it 9:30? Yeah, it's 9:30 for me, which is interesting because for me, the challenge opens up at 10 p.m. for me, 11 p.m. for Alka because he's in Central Time. he's been solving them on stream. But hello everyone from the Noise Brew stream. This is the Coding Garden, and this is my Wednesday stream where we solve Code Wars code katas, which are like code challenges. But it is currently Advent of Code, so. In 30 minutes, when this challenge unlocks, we're going to do this challenge on Advent of Code. Making a servo-controlled servo lift for my Twitch-controlled raid lights. That's awesome. Welcome. Yeah, all right. I have more chats to catch up on, I think. Oh yeah, so Pranjal asked the question. There's a backend built in Java using Spring, and it struts, and I want to test an API in it using Postman, but I can't do it as it always says session timed out. I would have to see the code or to try and help you debug or something like that. But yeah, that's a little specific. Cool. Filter is saying the biggest issue I found is that I made it modular and now I'm running into many issues since I'm not doing the majority of the work in index.js. Yeah, it's tricky, especially like if you're just new to creating modules in node.js. Like you have things in so many separate files and figuring out how to pass data around, it can be tricky. Yeah, thanks again for the raid, Noise Brew. Woo! John Cho is asking, a book you have in mind to learn more about important algorithms and data structures, etc. So this is I do mostly JavaScript on this channel. And there is a JavaScript data structures and algorithms book. Let's see. This repo has 57,000 stars. This is the one. JavaScript algorithms. So it's not a book, but this is an insanely great resource for learning data structures and algorithms in JavaScript. So check that out. How do I real-time update the count of the timer on the bottom chat comment? Oh, this thing. Yeah. So this is an Electron window. I built it on stream a while back. But it's running Vue inside of an Electron window, and I'm using the time ago package. And so basically every second I iterate over all message and get the latest time ago string. So time ago is a library for JavaScript, timeago.js. It's super tiny, but basically you pass it a timestamp and it will say just now or 40 seconds ago or 45 seconds ago. So basically every second I'm iterating over all messages and calling the time ago function to get the latest value to show here, which is why they're kind of like updating in real time. But the code for that is on my GitHub. Live chat window, I think, which is a part of my live chat manager, which is this thing that you're looking at, because it combines YouTube and Twitch comments. But we can see it really quick. I think it's in the renderer. Yeah, so literally every second I iterate over all the messages and call set time sent, and set time sent just calls time ago to format the time ago. Cool. Oh yeah, Filter says, it's been great. Found you through Insta's channel, and you guys have inspired me to finally pick up and work on learning. That's great. Love to hear it. And thanks for the follow, One Versus All. Nice. Oh, Advent of Code. I think I mentioned. Oh yeah, thanks for the link, Josh. And thanks for the follow, Noise Brew. My channel came recommended. That's cool. Thanks, Twitch. Sammy Bay. And thanks for the follow, VHGI. Sam is saying, for the anagram, how about getting the ASCII value of the characters in the string, then comparing if the two strings have the same value? That may or may not work, because you could have two letters that add up to the same value of a single letter in the other string that wasn't in the original string. Yeah, that wouldn't be like a perfect algorithm. Oh, Sammy Bay has a good book. Let's check it out. Yes, this is the one I was thinking. Or was it? No, it wasn't. But check it out. I really don't buy books. I mainly learn online, so I can't really recommend any of these, but feel free to check it out. Have I seen github.com/dadjokes? Let's check it out. That didn't find it. Dad jokes? See you later, Josh. Thanks for tuning in. Oh, there's West Boss dad jokes and Tim's Neath dad jokes. Oh. West Boss, okay. Hello, Danielle. Welcome to the stream. I've heard of it because I listen to Syntax FM, but I've never actually looked at the repo. How do you get the code for the bank vault? You check out their branch. How did the developer announce their engagement? They returned true. I don't know about that one. Why did the security conscious engineer refuse to pay their dinner bill? Because they could not verify the checksum. Yeah, these are great. I guess they accept pull requests for dad jokes. That's pretty cool. All right, we're 24 minutes away. Yeah. What's a good way to learn good commenting and documentation practices? I want to ensure my code is good for collaboration later on. We can talk about that. I'll save your question over here. Field Tour says, I hate to raid and run, but I need to get some dinner in me and get the kiddos to bed. Have a wonderful rest of the stream if I don't pop back in the chat. Thank you so much for the raid, Field Tour. Have a wonderful night and a good dinner. See you later. Okay, we're gonna hop into a 6Q. We only have about 20-ish minutes to do it, so we're gonna choose from. Oh, I hate this. I don't want to. The one with the squares inside the squares. I don't like it. Hello, Cheesy Bacon. What's up? Reverse or rotate. The input is a string of digits. Cut the string into chunks. A chunk here is a substring of the initial string of size SC. If a chunk represents an integer such as the sum of the cubes of its digits is divisible by 2, reverse that chunk. Otherwise, rotate it to the left by 1 position. It sounds doable, but weird. Weird. Okay, Pascal's triangle. Write a function that, given depth in, returns a single-dimensional array list representing Pascal's triangle from the first to the nth level. How about no? I only have 20 minutes. I guess we could just sit here and chat for the next 20 minutes. Have I done the snail kata? Nope. Do you know what Q it is? Can you link to it or tell me what's the name of the kata? Cheesy Bacon has a dad joke. Why did the frog cross the road? To show his friends he had guts. That's kind of morbid, right? That's not nice. Yeah. And hello, Samya from India. Welcome. Okay, maybe we just choose another 7Q because these 6Qs look really hard. A bookseller has lots of books classified in 26 categories. The first letter of a code is the capital letter of the book category. In the bookseller's stock list, each code C is followed by a space and by a positive integer, which indicates that the quantity of books of this code is in stock. For example, an extract of one of the stock lists could be try a 5Q. those are harder, Andrew. I mean, technically they're supposed to be harder, but these 6Qs, which were listed, seemed very convoluted. Hello, Greg. What's up? And thanks for the follow, Kane Freestyle. In this kata, you have to correctly return who is the survivor, the last element of a Josephus permutation. Basically, you have to assume that n people are put into a circle and that they are eliminated in steps of k elements like this. Have I done the directions reduction? No, I always skip it because it seems hard to me. Once upon a time, on a way through the Old West, a man was given directions to go from one point to another. The directions were north, south, west, east. Clearly, north and south are opposite, west and east too. Going to one direction and coming back to the opposite direction is a needless effort. If I can do it, so can you. Okay, let's do this one because I've avoided it forever. We're just going to jump right into it. And in 20 minutes, if we're not finished, we're going to stop and do Advent of Code instead. So let's do this. We will add it to the README. We'll create a file called directions reduction, recursion or riot. I may not do it with recursion at first. Maybe I will. Sometimes the recursive solution just makes more sense to me. But we'll see. But anything that can be solved with recursion can also be solved with a loop. Recursion is just looping on the call stack. It's a 5Q, not a 6. Yeah, I know. we're going to try it. So if we reduce this, so north, so you go north, you go south. You go south, you go east. You go west, you go north, you go west. The only thing you've done from the origin is you've gone west. So basically you need to reduce this to Oh, the README says 6? Oh, sorry. You're right. This should be 5. There we go. It's all good, Bob. It should be fun. But yeah, let's just read the description and then we'll try to do it. Yeah, I guess you can't send links, but if you in the URL, so click train and then send me the name that's in the URL. Morning Sage says that's easy. Actually, I'm thinking the same thing. We could basically represent it as a number, I think. Or like a coordinate system. Yeah, assuming numerical values of +1, -1. Should I skip the problem description and just try to do it? Freebly says 2 points. All right. Let me just look at what Ben sent really quick, and then we'll get started. I think, can we do this? Snail. Oh, snail sort. Yeah, I did this one. If you go to code-katas.now.sh, you can see a list of every kata that I've solved up until last episode. But I solved this in episode 14. Check it out there. Cool. Yes. What are the best free tutorials for Haskell? I have no idea. That's way out of my element. That's easy, Mr. Garden. Yeah, I'm thinking I might do like +1, -1. So like if you start off at 0, if you go north, you add 1. If you go south, you subtract. But we do need to the thing that's returned is still the list of the directions, so we can't really lose those. Okay. Integers seem a good solve. So I could probably figure it out, but the main issue is we need to keep track, or we need to hold on to the original like northwest southeast values. I'm thinking like if we're in a grid though. Plus I minus I. So we use, I mean, would that be like 2i, 3i, -2i, 0i? Is that what you mean? West would be any, any? Interesting. 2D vectors. Any negative. Yeah, so it could literally be, I see what you're saying. It could literally be anything. It doesn't have to be integers. Feel free to like link, if you put your solution like in a gist or something like that, feel free to link to it. Primes? We could use primes. How about we just talk about the problem for 15 minutes and not solve it? I don't know. Let's vectors are perfect. Okay, well, we'll try to use vectors. So I'm going to start up Quokka. Quokka is a nice little tool that will actually run my console logs inside of the editor. Hey, no worries, Bob. No worries. So we obviously need to iterate over the array. Look at the issues in the code Katas repo. Oh wow, there's a lot. I didn't even look at them today. You twitface. Numerical palindrome. I've already started, but I totally forgot that there are suggestions here. Well, we could do those later. Okay, so we need a place to store the reduced directions. And I'm just thinking like we'll like push into an array and then remove from that array if a particular direction negates itself. So, I mean, and then we'll need to iterate over the directions. So we're going to iterate over array. And then what do we do? So people are mentioning to use vectors. I don't really know how that would work. I'm trying to think, like, if we, so if we start iterating, so we have north, we push that into reduced reductions. Great. We have south. We recognize that north is already in the reduced directions, so we remove both of, wait, no. Yeah, so if we go north and then we go south, it's just negated itself, so those are gone. And then we go south, and then we go east. So really, like, the pairs of things negate themselves, right? So if there's a north and a south, those are gone. And if there's an east and a west, those are gone. If there's a south and a north, those are gone. Right? Am I wrong in thinking that? Right? So, I mean, I think we can actually, okay, we only have like 10 minutes, so I'm not even gonna like write the comments out. I'm just gonna do it. So I'm gonna say return array dot no. That's why it's a 2D vectors. Okay. You know what? What if... So the main issue is, I guess, they need to say in the right order. But what if I counted them up in an object? So, actually, okay. Like, I want a variable, use a stack. So many suggestions. I want a variable that's like where we've been. Let's just call it the past. This is going to be an object. And then we iterate over the array. And also we'll have a, I guess, do we need another array? If we iterate in reverse, is that a bad thing? Let's iterate in reverse, because I'm going to be removing things from the array. So we're going to go from, let's do this. Well, I is equal to array.length -1. While I is greater than or equal to 0, I minus minus. We're going to have each direction, and that's going to be r at I. And we'll say we need like a direction map. So like if we come across the south, we need to know that north is the negation of that. So like let's call this like opposites. And so we'll say north has south, and similarly south has north, and similarly east has west, and west has east. So we can reach into this object and say, okay, what's the opposite of north? Is it south? Have we been south already? Negate it. Okay, so we're going to say opposite dir is going to be opposites at that dir. Now we'll say if the past has seen that the opposite direction, then we're going to splice out the direction itself. Oh. So we're going to say array dot splice I 1. So we actually want to remove this direction if we've seen it before. Otherwise, we'll put it in past at that direction. We'll like increment it or decrement it. So this is what I'm thinking. And we're iterating from the end. So let's say we start at west. We grab that direction. The opposite direction is east. We're going to put west in this object. So we're going to say west is now 1 at this point because we've gone west once. Now we'll say if we've gone east, we actually want to remove it from the array and decrement this to 0. Cool. So west stays there because the east isn't in there yet. So we have west and then we have north. This isn't going to work because, yeah, so we have north. We haven't seen it yet. We have west. Now the count is 2. Now we get to east. So we put past at east. We increment it to 1. So we've been east once. If we've been past at west, yes, we have. So we actually remove... oh, we need to remove both of them because they cancel each other out. Ah. Okay. So we should actually not store just the count. We need to store the index. Right? Right? I don't know. I'm just writing code at this point. We only have 6 minutes to solve it, but we're gonna get it. We're gonna get it. Let me catch up on the chat. Oh wow, there's 40 messages. I don't know if I could do that. Oh, Sundar Pichai became the CEO of Alphabet. Leave the order intact. Could you search replace forward opposite? That would leave the order intact. Okay, vectors, man. I don't know what you mean by vectors though. Like, it seems like it might be good. Okay. Yeah, we'll take a look at your code afterwards, Bob. 2 variables, vertical movement and horizontal movement. Oh. But we... Well, that makes sense to me, but we lose the order of when we went to given direction. So, yeah. Use a stack. Then you can push and pop depending on the direction. True. I like that. We're going to keep that up. And there's Bob's code. What if you use the anagram logic, count times, and remove opposites? It needs to maintain order, though. Vectors. It's like 2 variables. Okay. And thanks for the follow, Briosu. Welcome. Chris Code Cole says, in the notes, they mentioned that they only cancel if they fall next to each other, like Tetris. If a pair gets removed and another pair are together, then you can remove that second pair. This is my advent of code alarm. We have 5 minutes. I'm going to set another alarm. Okay. Here we go. So, I hate to do this, but I do need to take a break. Here's what's going to happen. When I come back in 4 minutes, we're going to solve Advent of Code. After that's done, we're gonna finish directions reduction. I can't not finish directions reduction, but I am gonna take a quick break. Yeah, so tuples, what you're all saying makes sense. I'm going to leave all these comments here because it makes a lot of sense. I just need to figure out how to actually do it. But take a quick break, back in 4 minutes to solve advent of code, and then we'll come back to the directions reduction. Sorry for being all over the place, but we'll be back. You can play the drop game while I'm gone. See you soon. Hello, I'm back, and it's been unlocked. Let's do it. Advent of code. I'm out of breath. I had to run down the stairs. Okay, I'm not going to be able to catch up on the chat because we want to get on the leaderboard. I need to catch my breath. Okay, day 5. Sunny with a chance of asteroids. You're starting to sweat as the ship makes its way towards Mercury. The elves suggest that you get the air conditioner working by upgrading your ship computer to support the thermal environment supervision terminal. um, The test starts by running a diagnostic program, your puzzle input. The test diagnostic program will run on your existing int code computer after a few modifications. Oh, okay. So on day 2, I implemented this int code computer. So apparently I need to reuse that. I need to add 2 new instructions and add parameter modes. Okay, I need to get set up locally. So, I do have an advent of code directory. I have a 2019. Let's make day 5. And, oh man, I remember now. I actually solved day 2 like in the browser. Like I didn't even pull the code down locally. So yeah, this is it. This is the input for that. Yeah, so let's go into the 05 directory, open code inside of there. New file, index.js. We'll throw that there. Cool. We don't need that. Why is this complaining? Okay, so that's our int code computer. Cool. And then we need to add 2 new instructions. Programs that use these instructions will come with a documentation that explains that should be connected to the input and output. The program 304099 outputs whatever it gets as input, then halts. Second, you'll need to support parameter modes. Cool. This is so much. Okay, I need to get my puzzle input. And here it is. Yeah, so this is like the int codes. Oh, not that. So this big long string of numbers here is the memory of my computer here. Like that. So we need to change that. And before we were overwriting memory at index 1 and 2. I don't know if we still need to do that though. I'll have to read the instructions. And so yeah, this yeah. I realized for those of you that haven't done advent of code, like this int code computer is like completely like you don't even know what we're talking about here. But yeah, so if you go to adventofcode.com, there's basically a daily challenge, and there's 2 daily challenges leading up to Christmas, so it's 25 code challenges, and there's a leaderboard, and I have a feeling that I'm not even going to get on this leaderboard because this is a very hard problem. Basically, you have to be the first 100 people to solve a given day's challenge to make it to the leaderboard. But cool, let's do this. Okay. Don't explain, get to coding. All right, so opcode 3 takes a single integer as input and saves it to the address given by its only parameter. For example, the instruction 3 and 50 would take an input value and store it at address 50. Okay, so basically the way that I created my computer is I have these different operations. And basically I need to say if the operation is equal to 1 or the operation is equal to 2, that's when we do all of this stuff. Because otherwise, we need to handle the 3 operations. So we'll say if opcode is 3, so takes a single integer as input and saves it to the address given by its only parameter. For example, the instruction 350 would take an input value and store it at address 50. Take an input value? But what's the input value? Opcode 4 outputs the value of its only parameter. For example, the instruction 450 would output the value at address 50. But where does the input value come from? That's what I'm curious about. I'll go ahead and add the else if, because we are going to have to handle operation 4. So that's fine. Programs that use these instructions will come with documentation that explains what should be connected to the input and output. The program 304099 outputs whatever it gets as input and then halts. Input, stored at address 0. Output, what's at 0. Because it's 3 and then 4. Okay? They have some examples down below. That might help. Second, you'll need to add support for parameter modes. Each parameter of an instruction is handled based on its parameter mode. Right now, your ship computer already understands parameter mode 0, position mode, which causes the parameter to be interpreted as a position. If the parameter is 50, its value is the value stored at address 50 in memory. Until now, all parameters have been in position mode. Yeah, so just to talk about what's happening here, basically this stream of inputs are operations on a computer, and operation 1 says to take the value at this index in the array and add it to the value at this index in the array, and then store it at this index in the array. So that's what the 1 operation works as, and that's what this code is doing. Basically, it looks at all these values and does those calculations, and then 2 is very similar, but it just does multiplication of the values at those indices. And basically, this array is a big, long array of all the memory of our computer that we're calculating. And so what they're saying is when we're in position mode, which is what I was used to, 238 refers to the 238th position in the array, and 225 refers to the 225th position in the array. However, now we need immediate mode. So now your ship computer will also need to handle parameters in mode 1, immediate mode. In immediate mode, a parameter is interpreted as a value. If the parameter is 50, its value is simply 50. Ah, I see. So in immediate mode, instead of looking up the value at index 238, you actually use the value 238. Okay. Okay. Parameter modes are stored in the same value as the instruction's opcode. The opcode is a 2-digit number based only on the 1s and 10s digit of the value. That is, the opcode is the rightmost 2 digits of the first value in an instruction. Parameter modes are single digits, 1 per parameter, read right to left from the opcode. The first parameter's mode is the hundreds digit. The second parameter's mode is the thousands digit. Wait, hundreds? The second parameter's mode is, the third parameter's mode is the tens digit, and so on. Any missing modes are 0. So for example, consider this program. The first instruction is a multiply instruction. So the rightmost 2 digits of the first value, 0, 2, indicate opcode 2, multiplication. Then going right to left, the parameter modes are 0, hundreds digit, 1, thousands digit, and 0. Oh, I see. So 4 is an immediate value. 0, we look up the value at indice 3. 4, we look up the value at indice 4, because these are the operations. Yeah, so the opcode includes what the mode is for each of the parameters to it. Hello, Alex. The first instruction is a multiply instruction. Then going from right to left, yeah. Two-digit opcode. Mode of the first parameter, position mode. Mode of the second parameter, immediate mode. Yeah, immediate addressing. That's what they're calling it. So basically, instead of looking up the value in memory, you use that value itself. I'm still just trying to interpret this, make sure I understand it right. Oh, omitted due to it to being a leading zero. Ah, okay. So we're going to have to parse the opcode, but I think I get it now. So the opcode is the last two digits. So 02 is opcode 2. And then 0 is going to be address mode for the value 4. So find the value of value 4, which is 33, I think. 0, 1, 2, 3. Yeah, so 33. And then, hello, Ozishan. We're solving advent of code. And we were kind of on a time crunch, but I realized this is going to take me a while. But if you go to adventofcode.com, there's a code challenge every day leading up till Christmas. And this is today's challenge, which came out 11 minutes ago. I'm already 11 minutes behind. Dang it. It sounds like a homework assignment from a CS class. Yeah. Okay, so this instruction multiplies its first two parameters. The first parameter 4 in position mode works like it did before. Its value is 33. The second parameter 3 is in immediate mode, so we do 33 times 3, which is 99. And then we store that at position 4, so we're going to store 99 right there. Parameters that an instruction writes to will never be in immediate mode. Finally, some notes. It's important to remember that the instruction pointer should increase by the number of values in the instruction. After the instruction finishes, because of the new instructions, this amount no longer is always 4. Oh. Integers can be negative. Oh, this is so tricky. Jeez. Okay. I wonder, is Alka live? So Alka usually solves these things. Actually, let's just see. Let's take a quick stretch. Yeah, Alka's live. So if you wanna watch Alka solve it, you can go over to his channel. We're trying to solve the same problem simultaneously, and we usually both have very different approaches. What's that? Okay. But the test diagnostic program will start by requesting from the user the ID of the system to test by running an input instruction. See you later, Ben. Thanks for tuning in. The coding jargon. Where 0 means the test was successful. Wow. Okay, so looking at this input, let's see. Like 3 is an opcode. That's opcode 0? Or is that a value? That's an opcode. Okay, so basically we'll need to parse the opcode. So like in this scenario, opcode 1, and we default to memory mode. So we'll be looking it up. Similarly here, no, there's that. And then this is opcode 2 with 0, 1, 1. Wow. Okay, I'm still not clear on what happens with opcode 3 and 4. Oh. For example, the instruction 350, so that literally takes the value 50 and stores it at address 50. Opcode is 2 digits, though. It varies. So in this scenario, the opcode is only 1 digit. The opcode here is 1 digit. The opcode here is 4 digits, which we need to parse. And then this opcode is 1 digit. So I think if the opcode is 3, we can say input, say value is going to be input at I plus 1. Yeah, so O2 is the opcode, and then 1, 1 are the types, or is the operation type, and then there's a leading 0 because there's always going to be 3 operation types, I think. We'll come back to it. But what I think this opcode 3 is saying is you take that value. So if I is 0, we currently have 3. And if... so we get this value, and then we store it there. So we'll say input at that value equals that value. And then we increment I by 2. Because I was 0, 1, 2. And then on the next iteration, we have opcode 1. So that's great. 1, 2, 3. Yeah. Okay, so that's great. And then what was opcode 4? So opcode 4 outputs the value of its only parameter. For example, the instruction would output the value at address 50. Oh, output like a oh. Like it logs it? Let's see. So again, the value is going to be I plus 1. And then I don't know what it means by output. Maybe we need to store an output somewhere? Like we have an array of outputs? Maybe that's it. Because here, for each test, it will run an output instruction indicating how far the result of the test was from the expected value. What does it mean by output? Oh, what should be connected to the input and output? The program 304099 outputs whatever it gets as input, then halts. Huh. Okay, I'm curious because I'm already 20 minutes in, but I wonder if the leaderboard, like if there's already been people that have finished day 5. Wow. There's only 68 of them though. Oh, wait. Yeah, so 100 have completed part 1 and 68 have completed part 2. Wow. Wow. Okay. This is so confusing. But what does it mean take an input value? Does that mean it's itself? I need more examples. Okay. easy enough. I want to look at other potential opcodes. So there is okay, we need to check the opcode length. So so if we take the opcode, which is either 1, 2, 3, 4, or something weird like this, and if the op string dot length is greater than 1, then we need to change the operation mode based on that. So yeah, if the length is greater than 1, we want to pad it with zeros, so that way we can get the operation mode of each thing. And I think we need 3. 3, 4, 5. Yeah, so the total length should be 5. So we'll pad it with zeros to get us to length 5. Isn't there like a pad start? Let me look that up. So we want to pad it to length 5 with zeros. And just to get this working, let's say opstring at opstring.length minus 1. Turn this into a number. So that should do the thing. Let's just see what happens. I'm gonna run the code. Infinite loop. 0, 1, 3, 2, 5? What? Where's that even coming from? But basically what I wanted to do was take an opcode like this, pad it with zeros. So let me see how this would just work really quick. So if we take, for instance, that and say pad start, so that pads it, so that way we have the operation mode of each one. Cool. Yeah, somehow we're getting opcode 5. Really curious how Alka is doing.
Do they want you to keep adding to what you had the previous day? This separate challenge. Sometimes they will like continue.
Yeah, he's still working on it. Let me catch up on the chat because this is gonna be way harder than I thought, and it's gonna take me a while. But we're gonna finish it. We have to. Let's see. Primes. Good morning, Alana. That was 22 minutes ago. I don't know if you're still here. Pranjal is asking, have I built a node backend in a microservice architecture anytime on stream? No, I haven't built microservices on stream. Hello, Ozma. Welcome to the stream. Yeah. Yes. This reminds Ashwin of Project Euler. Yeah. Dean is saying, wish you could make a Feathers.js / React miniseries. That would be fun. I recently came across Figbird, which is a really cool library for interacting, like React library for interacting with the Feathers backend, but it has these hooks like use get, use find. It's pretty sweet. And thanks for the YouTube sub, Jeremy. Divakar says, this is my first time chatting with you, CJ. Will you make a Maven stack after some time? Probably. That's Mongo Express View in Node? Yeah, eventually I will. Hello, Gustavo, and hello, Jorge. Sage says, I'm going to start at the beginning and solve these. I believe in you, and the ones leading up to today were actually fairly easy, I think. Fairly easy. This is hard and hard to comprehend even. And also, I don't understand why I'm getting the same... I think this is why. Somehow we're getting the opcode 5. Quick stretch. We've officially been working on this for 28 minutes, and I've literally gotten nowhere. Let's see. Invalid op 5 at index 6. 0, 1, 2, 3, 4, 5, 6. Ah, okay. So somehow, when we take this number and we turn it into a string... Actually, I want to log the op before we turn it into a string. Oh. 1325. Because it gets modified by a previous one. Huh. So input location is 1, 2 is here, so 6. Left is 225 is 6. Yeah, so that's overwriting that location. And that's not a valid opcode. What the heck? Okay. It is important to remember that the instruction pointer should increase by the number of values in the instruction after the instruction finishes. Because of the new instructions, this amount is no longer always 4. Line 26, overriding my original input. Yeah, it's supposed to. So that was based on the original rules of this computer. And hello, PCL. But yeah, the original rules of this computer are when you have an opcode 1, The first item is a memory address. So we would look at index 225, get that value. The second item is another memory address. So we'd look at index 6. So that'd be 0, 1, 2, 3, 4, 5, 6. So we'd look at that. And then because it's opcode 1, we add them together. And then this is what location we should store it at. So 0, 1, 2, 3, 4, 5, 6. So it is supposed to overwrite it. But now that it's overwritten it, this is no longer a valid opcode? Or like, what is that even doing there? No, not that. This. But yeah, when it overwrites it, that gives it the value 1325. 5 is not a valid opcode.
String them 26 times and 27 times. That's what I'm hoping for.
So this is Alka. He's solving the same thing at the same time as me. I'm curious how far he's gotten.
I've only played a little bit of Halo. So, first of all, I never had an Xbox, so I could only play at my friend's house whenever I went there. But hey, Kebabs, how's it going?
I'm gonna chat with him.
We're just slowly reading this. We have yet to finish reading. Hey, CJ, how's it going? How's your stream? Very confused on this one. Yeah, I'm still reading it. Still streaming? Gotcha. How's it going?
It's pretty good. It's good.
Yeah, I've got the last three paragraphs to look here. I don't even know what the final thing is. I've copied over my code from day 3 or whatever, or day 2. Get back to it? Alright. I'll let you know if I figure out anything.
Yeah, so he's still reading through it. we're 33 minutes into the challenge. He's still reading it. So, yeah, hey man, you finished this homework yet? Pretty much. That's pretty much what just happened. Like, so right out the gate, this is very weird. So the fact that it's like position 6 is overriding this with the value 1325, and that is not a valid opcode. Means like something really weird is happening. Oh, I think we have to change the default mode. Yeah, what's 225 plus 6? 231? That's not right. Let me see though, because your ship computer will also need to handle parameters in mode 1. Okay, never mind. So it actually mode 0 position mode is the default, meaning like a memory address. So like 225 isn't a memory address. Yeah. And hello, Nar. Welcome to the stream. Alana's working on algorithms. Cool. All right. I thought this was going to be way easier. I thought it'd be done by now. Okay. 1002434333. Great. Jorge is saying, what if we try to solve it together? We could. But it's a bit of a competition. Oh yeah, so the other thing I didn't mention is we have a Coding Garden leaderboard. You can see it here. And Alka's at the top. He's beating me by a little bit. But if you join the Coding Garden Discord, there's instructions on how to join this leaderboard. And that's mainly why we're not gonna work together. I mean, maybe we could, but yeah, I'm gonna try to solve it without him first. And thanks for the follow, Ahira. Welcome to the stream. And Bob did part 1. Yeah, so anyone out there watching, feel free. Go to adventofcode.com and you can sign up or sign in with GitHub and then start on day 1 and work your way up. I have full confidence that you can at least make it to day 4 because I made it to day 4. But today, day 5 is a doozy. Yeah, should increase by the number of values in the instructions after the instruction finished. What that means is that when you have opcode 3 or 4, it only increments by 2. Whereas if you have opcode 1 or 2, it increments by 4. I think it's in the general channel, Bob. Let's see. Or is it in live chat? Oh, it's in live chat. So if you go in the live chat channel and scroll up, actually I can do this. Yeah, I'll share it now. Cool. I don't have to worry about negative just yet because it's breaking at the beginning of the input. The test diagnostic program will start by requesting from the user the ID of the system to test by running an input instruction. Provide it 1. After providing 1 to the only input instruction and passing all the tests, what diagnostic code does the program produce? What? What? Is it possible that... Hello, Baskin. Is it possible that I wasn't supposed to replace the computer's memory? Like, I was supposed to use the computer's memory from the previous challenge? I don't think so. Parameters that an instruction writes to will never be in immediate mode. Ah. Okay. What am I doing wrong? I'm going to look back at my original int code computer. I do think I'm supposed to give it a different input. Like, this is supposed to be the input for it. I just sent the message on YouTube, Ashwin. So that recent message has the leaderboard code that you can enter to join this leaderboard. Okay. And thanks for the follow, Napcats. Welcome. I need to take a nap. Opcode 3 takes a single integer as input and saves it to the address given by its only parameter. But what does it mean, take an input value? But what does it mean? Hello, Dirkgirl. Oh, output the value at address 50. regardless. The program that uses these instructions will come with documentation that explains what should be connected to the input and output. The program 304099 outputs whatever it gets as input, then halts. Yeah, immediate mode. Okay. Parameter modes are stored in the same value as the instruction's opcode. The opcode is a 2-digit number based only on the ones and tens digit of the value. Yeah, so like in a 4-digit thing, 02 is the opcode. Have that. Nara is asking, is it possible to learn data structures in JavaScript frameworks by practicing 2 hours a day each? Yeah, I don't see why not. I can't say how long it would actually take you to get good at it or know enough about it, but I think that's a good approach. Just work on it a little by little every day. I'm going to ask Alka for his input.
So what's place 255? So what is it now? What was it? Alright, so what's the difference here? So what does it do? This like replace the output value. I'm probably gonna read day 2. Let's go read day 2. Look at this, yeah.
I want to see if Alka will send me his input.
It's like a really simple. I don't know. We'll figure it out. Considering your input and running into an issue.
Cool.
Let's see. Oh, nice jump, Cat. That was good. Really, she jumped from the thing next to me all the way to the end of my desk. That's interesting. Where are we? Advent 19.
Nara's asking, is React a good place to get started? I would really only start in React if you've already been coding in JavaScript for a while. I wouldn't jump directly into React unless you know a good bit about, or a decent amount about JavaScript. Okay, let's see what Alka's input is.
I'm just trying to.
His is the same. It's very similar.
So we don't really want what day 2 is doing necessarily. Day 2 is sort of like putting in a bunch of values and then doing the same thing until we get an output that we want. So day 1 is the correct thing to have. We don't need the hard coded values. We somehow need to have an input that 3 can take in.
He has a very similar input.
Just the input. So is there more 3s? 3 codes? It's kind of hard to tell. First of all,
okay, so the beginning of his input is exactly the same as mine, and I run into the same issue. Where basically, so 3225, so opcode is 3. It takes the input at that memory address and sets it to 225. Then we have opcode 1, which is addition. We find the value at 225, which is 225 because it just got stored there. And we add that to the value at 6. The value at indice 6 is 0, 1, 2, 3, 4, 5, is this. So 1100 plus 225 is 1325. And then we store that at address 6. So this becomes 1325. Cool. And then this was that operation, so we move on to here. And this is not a valid opcode. This is not a valid opcode. And thanks for the follow, Nar. 1 is a valid opcode. Should we be incrementing by 5? There's only 4 values in the operation. Huh. Hello, Nunib. I'm actually not solving katas right now. I'm solving Advent of Code. So if you go to adventofcode.com, these are daily code challenges leading up to Christmas, or December 25th. So I'm on day 5. And if you, well, I guess it's not in the Twitch chat, but here, I'll send you this. And we have a Coding Garden leaderboard for anyone else that wants to join or participate. Here. And this is anyone that's joined our private leaderboard. Alka and I are at the top. We're currently working on day 5. Hello, Kudaji. Doing pretty good. Actually, I'm not doing that good. I'm really stuck on this, and I don't know why. It's writing of so. Oh, you know what? I think the input to the program is the value 1. And I think this is where I'm getting confused. So when the operation is 3, we need to store a value at this memory address. But what value do we store there? Do we store 225 there? Opcode 3 takes a single integer as input and saves it to the address given by its only parameter. Okay, so I think this is where I'm messing up. So instead of putting the value 225 at the memory address 225, we actually would want to put the value 1. Because then, if we added 1 to this, then this becomes opcode 1 with some extra stuff on it. I think that's where I've gone wrong. Okay, this is good to know. After providing 1 to the only input instruction and passing all the tests, yeah, so this thing takes in 1 as input. And then output? Okay, but let's just say right now that well, instead of calling this input, let's call this memory, because that's kind of what it is. It's like the memory of the computer. And technically, this input value is 1, because we're putting 1 into the computer. And so when a 3 happens, we need to grab that memory address and set it equal to input, because that's going to be 1. And that becomes 1101, which is a valid opcode. Okay, I think I'm making progress here. Cool. So output at value So there's that. Okay, so given that, now we're going to put 1101 here. And this is a bit better because, yeah, cool. So this very first one becomes 01101. And so the opcode actually becomes 1. So that's great. And then the modes are going to be the first 3 values in there. Cool. So here's what we'll do. Let's say modes equal 0, 0, 0. So it defaults to mode 0. And I believe mode 0 is the default, right? Position mode, yes. So we're going to default to 0, 0, 0. But if it's greater than 1, then we're actually going to change that. So we're going to say modes are equal to the op string, the first 3 values in the op string. From 0 to 3. Yep. 0 and 1, 0, 0, 1. So 0, 1, 1 is this one. 0, 1, 1. Cool. Kaduje says, you have so many nice stickers on your laptop. Thank you. Thank you very much. Yeah, it's still December 4th for me. I have about an hour until December 5th. Okay, so now that we have modes, we can determine what to do if the opcode is 1 or 2. So input, so left, memory at, okay, so left value equals modes at 0. If that is equal to 0, then memory at left. Else, you literally just get the left value. And then same thing for the right value. Modes at 1 is equal to 0, then memory at the right value. Otherwise, you just get right. Left value, like that. Though, we have 3 opcodes. What do we do with the third one? Does that have to do with the location? I don't know. And hello, my coding journey. And thanks for the follow, Technoboard, or Technobard. Let's look back at what happens with these opcodes. The mode of the third parameter is position mode. It seems like the third parameter is always going to be position mode, because that's where the result gets stored into. Like if we look at this, no, that's wrong. Let's try running it again though. Okay, so that's messed up. Here, we're gonna log the op string and the modes for each one. Yeah. Oh, I have to take into account for for opcodes 4 and 3 as well. But is it ever anything different than 0 at the beginning? It always starts with 0. Okay, so we actually do need to be reading from right to left. Let's go back to this. So mode of the first parameter. Oh, I see. Modes at 2 is the modes of the first parameter. Modes at 1 is the left. Cool. And then similarly, when it's opcode 4, if yeah, and it's going to be modes at 2. So if modes at 2 is equal to 0, then it's memory mode. Otherwise, it's value mode. For there's only one opcode 4. Okay, so I think we're doing good there actually, and we can stop logging this. Take a quick stretch. Okay, and that's Alka's input. We want my input. All right, so if we run it, it gives us this output. What does it mean? I don't know. What are we supposed to do with it? Indicating how far the result of the test was than we expected value, where 0 means the test was successful. So did we output 0? Yeah, we outputted 0 for everything, which means the test was successful. What diagnostic code is the is this the number? Is this the answer? It would be crazy if this is the answer. Submit. It's the answer. Oh my goodness. We did it. Okay, so what we did wrong. I had no idea what they meant by input. And basically, we were adding 225 to this number instead of adding the input 1. Okay, we did it. All right, let's go to part 2.
I do enjoy that type of stuff. This is Forge. Yes, Forge. Oh, you did part 1? Oh, you're popular? So damn confused? Oh, well. We figured it out, huh? I'm sort of working on it a little bit. I'm just trying to figure out what the third parameter would do if it was an immediate mode for anything other than output. Just trying to figure that out. So how'd it go? Was it more simple or more difficult than you expected? Keyframe was realizing what they mean by input, right? I'm not entirely sure. I feel like it's just set it to whatever the position is it's trying to do. I was looking at the input. It's just so it's immediate, not immediate. It's position mode, wherever 255 is. But I noticed there's a lot of 225s, so I'm not sure what that's going to be. Especially when mine says input. Yeah, mine does too. Mine says position 1. So over here I've got input data is 1. So when there's a 3 opcode, 1 gets stored at that address because 1 is the input. Right. I've understood that now. But first I was not sure. Am I what's holding me back. I think I've got that. So maybe this will be smooth sailing.
Cool. Yeah, so Alka's working on the same problem. I can't believe I did it. All right, now we're on to part 2. So usually these problems are split up into 2 parts. We just did part 1. Part 2 usually uses the code, the same code, but adds some... Yeah, so you'll notice here they're adding more opcodes. So we're going to do that. I'm going to catch up on the chat, and then we'll keep going. This advent must... Yeah, so this stuff is intense. And I think it's actually multiple people that submit the challenges. It's a really cool format, though, because you can literally solve these challenges in any programming language, because they provide sample input, and you just have to provide the output value. And they might have coded it like in Python, but you can code it in whatever you want as long as you get the right input. Oh, Sean, I fell asleep, but it's already finished. Well, we figured out the first one, which was actually not that hard. Ultimately, like, parsing the opcode, easy enough. Just realizing that we need to use the input value of 1 was my mistake. Okay, so part 2, the air conditioner comes online. Its cold air feels good for a while, but then the test alarm starts to go off. Since the air conditioner can't vent its heat anywhere but back into the spacecraft, it's actually making the air inside the ship warmer. Huh. Instead, you'll need to use the test to extend the thermal radiators. Fortunately, the diagnostic program, your puzzle input, is already equipped for this. Unfortunately, your encode computer is not. Okay, so your computer is only missing a few opcodes. Opcode 5 is jump if true. If the first parameter is non-zero, it sets the instruction pointer to the value of the second parameter. Oh, that's cool. Otherwise, it does nothing. Opcode 6 is jump if false. If the first parameter is 0, it sets the instruction pointer to the value from the second parameter. Otherwise, it does nothing. Okay. Opcode 7 is less than. If the parameter is less than the second parameter, it stores 1 in the position given by the third parameter. Otherwise, it stores 0. Okay. Opcode 8 is equals. We're building a computer. This is insane. Like all instructions, these instructions need to support parameter modes as described above. Okay. Normally, after an instruction is finished, the instruction pointer increases by the number of values in that instruction. Right. However, these jumps are different. So, however, if the instruction modifies the instruction pointer, like jump if true or jump if false, that value is used and the instruction pointer is not automatically increased. Yeah, so that's going to be a little tricky. For example, here are several programs that take 1 input, compare it to the value 8, and then produce 1 output. Using position mode, so opcode 3 takes the input of 1 and stores it at position 9. We then have opcode 8, which is equals. So if the first parameter is equal to the second parameter, then it stores 1 at the position given by the third parameter. Otherwise, it stores 0. Okay. Cool. So I think we can do opcode 7 and 8 pretty easily. So if op is 1, 2, or op is 7, or op is 8, then we need to add those operations up here. So operation 7 takes in 2 values, and it does less than. So if the first parameter is less than the second parameter, it stores a 1. So if A is less than B, then return 1. Otherwise, return a 0. So if the first parameter is less than the second parameter, it stores a 1. Otherwise, it stores a 0. So 1, 0. Cool. Now for opcode 8, if the first parameter is equal to the second parameter, so we'll do equal, store a 1, otherwise store 0. Easy enough. So opcode 7 and 8 are taken care of. We're already parsing them and changing the mode if we need to. And it will still always increment by 4, so that's great. Now we need the opcode 5 and 6, which are jumps. Okay. Opcode 5 is jump if true. If the first parameter is non-zero, it sets the instruction pointer to the value of the second parameter. Otherwise, it does nothing. Okay, I want to see some examples of opcode 5. Here. So, if the first parameter is non-zero, it sets the instruction pointer to the value of the second parameter. So go to 22. Otherwise, continue. All right. And we still need to do the same thing there in terms of taking into account the mode type. Cool. Hello, Terminal Bash. Yeah, everything's good. I'm working on Advent of Code. I was doing Code Wars Code Katas, and I was working on the directions reduction, but they released day 5, and I want to finish this, and then we'll jump back into that kata. Okay. I think I can handle this. Basically, we need to do some similar things here. We're not going to need all of that, but I want to do it anyways. but we'll use it. So basically, well, there's only going to be one parameter. Let's just call it param. And that's at I plus 1. And then we'll call this param value. So if mode's at 2... So for instance, 0, 1, 2. So mode's there, that's 0. Then we'll say memory at the param. Otherwise, the param itself. And the way this works is if the first parameter is non-zero, it sets the instruction pointer to the value of the second parameter. So if param value is not equal to 0, we'll say I equals the value of the second parameter. Well, that's tricky because here, this is direct access. Well, no, this is access memory access mode, and then this is direct access mode. Weird. But won't it always be? Yeah, I think it's all. If it's, it always will be. Okay, so I equals memory at I plus 2. Continue. And then the other opcode is jump if false. So if the first parameter is 0, so basically we do the same thing. And then it jumps. And if we look for opcode 6, it's always memory mode for the jump address. Yeah. However, if it wasn't, we need to increment I by 3 because so, well, let's say this. So if our pointer is currently at this memory address 1006 or that value, if this is 0, we're going to jump to 31, but if it's not, we continue. So we need to increment by 3 to skip to the next opcode. Cool. Here are some jump tests that take an input, then output 0 if the input was 0 or 1 if the input was non-zero. Okay. The above example program uses an input instruction to ask for a single number. The program will then output 9999 if the input value is below 8, output 1000 if the input value is equal to 8, or output 1001 if the input value is greater than 8. We're basically building a computer. This time, when the test diagnostic program runs its input instruction to get the ID of the system to test, provide it 5. So now our input is 5, and we'll just run it. Invalid op 0 at 6. I think we have an infinite loop. The ID for the ship's thermal rating show. This diagnostic suite only outputs one number, the diagnostic code. What is the diagnostic code for the system ID 5? Okay, I think it's wrong. This is wrong, but we're just gonna try it anyways. and then we'll fix our code. Yeah, this is wrong. I shouldn't have even tried that. But let's see where we're going wrong. So invalid operation 0 at indices 6. Wait, what happens if we input 1? Oh. Oh, I see. When we provide it 5, that changes the program entirely. So before we were providing 1, and that adds 1 there. But when that adds a 5, we're going to get 1105. And so that's going to be jump if false. Oh, jump if true. If the first parameter is non-zero, it sets the instruction pointer to the value of the second parameter. So if the is non-zero, I equals memory at I plus 2. 1, 2. So that's going to jump to address 238. Yeah. So we're missing something. I don't know what though. We're outputting at address 225. If we go back to 1, works great. Okay, so that's fine. Let me just make sure I got these opcodes right. So for opcodes 7 and 8, it should still increment by 4, right? Oh, I need to take into account negative. Integers can be negative. 100 plus -1. Okay. That's fine. I'm going to log when opcode is 5 and make sure we're doing the right thing. So we're going to log the operation and then memory at I plus 1. And the operation is memory at I. Yeah, so. Hello, Be Monstrous. Welcome to the stream. We are currently working on Advent of Code. We're on part 2. I don't know what's going wrong, so we're going to try to debug it. Modes 0, 1, 2. Ooh. Are we still padding it with 5? 2, 3, 4. Yeah. So we're still going to pad a 0. 0 is going to be at memory address 20. 1 is directly memory address 22. I may need to do this. Well, I don't want to call it memory value. What do we call this thing? Position? Let's call it position. So if mode's at 1, memory at wait. I'll call it value. So the value is I plus 2. And then if the mode is 0, then that means we want to look it up. Otherwise, if the mode is 1, we just grab the value. And we'll use that position there. And now we want to do the same thing here. The thing is, it's usually always 1, but maybe sometimes it's not. Yep, sometimes it's not. I think this is our answer. Okay, so I initially assumed that we can go back to the description, but I got it, and we're on the leaderboard, or at least on the private leaderboard. I'm at the top, 212. It looks like Tommy and Doc are. I don't know if you guys are watching, but I guess they're working on it too. But I'll tell you where I went wrong. So what I assumed was anytime we had an opcode 5, I assumed that the first one was always a 1, but apparently it's not. And similarly for opcode 6, it's not always a 1. Sometimes it can be a 0, and if it is, we need to actually look up that memory address value. But we've done it. We've done it. We can clean up our code a little bit. Let's see. Yeah, let's put this in a function. And are we using opstring anywhere? No, we're not. Okay, so we need a function. It's called like get modes that takes in the op and then does this. Really? I kind of want to do this. Op and modes. comes back from parse op. So we create this function called parse op. That's going to return an object. That has the op and the modes inside of it. So we're just going to return an object with modes and the op. So that should be good. I don't think we're using anything anywhere else. Invalid op 9 at 676. Oh. I see. Because if op is 99, we immediately just need to return. Because I was parsing the last value 9. Return op. Like that. Because that should do this. It'll break out. We'll be good. Cool. Great. That's fine. Op4 looks good. The one thing I do want to refactor is 5 and 6, because the only thing that's different is comparing the value. So I want to create a function that's like jump to. And we'll take in really this. No, like our comparison function. And we'll take in I, the current value of I, and we'll need to return it. Let's see what happens if I try to just refactor this. Like if I, oh, we don't need to log that anymore. But if I just grab this and say refactor, extract to function in the global scope, we'll say jump true. Actually, it's jump if true, I think. So jump if true takes in the memory, takes in I, and then the modes of access. Cool. So one other thing that we'll take in is a function that if it returns true, we're going to modify I. So let's call this comparison. And we're going to pass in compare value. So compare with compare value. If that results in true, then jump to that. Let's call this jump to. That. And so what we'll do is we wanted to jump to, and we get a value. We want to return, is that value not equal to 0? Like that. And here we're going to jump to if that value is equal to 0. Like that. Yeah? Seems to work. Looks like I lost my logs output at. Huh. I'm not seeing any other outputs. Oh, I broke something. I think. Or did I? 3892695. Is that the right value? 3892695. Okay. Cool. So that was a nice cleanup. And let's do this. We're gonna take in the input and memory. So we'll say try input with 5 and that value. Water, yeah, I don't have any water with me, and so that still works. Cool. So this is my solution. I'm happy that we made it that far, and we beat Alka to it, and that's at the end of the day, that's all that matters, right? Oh no! We technically got it first. We got it first, but Alka got it.
You know, I think I can get into it. It's just, it takes a little bit of setup. So it's not something like I'm going to get into it really get scripted. Right now I'm just like copy paste. Versus have to. So I did it. I did it. It's pretty awesome. Let's see. Let's try it. Times. And really not that. What's your solution?
Yeah, I'm gonna send him my solution. Interesting. Okay, we need to get back to that code kata, because then I gotta go to bed. It's already 11:30 here. I do want to see what Alka has to say about my solution though. We'll wait for him. He's working on things. I should probably go get some water. Yeah, I'll be right back. I'm gonna get some water. I'm back. I have my invisible water. That's so cool. That's great. You can't even see it. Good morning, Abdelhamid.
And then I also offered this as a ternary, so based on the
So we're seeing how Alka solved the same problem that we were just working on.
And then moving the increment part down to each opcode section. Sometimes it changes, right? What place did you get? I think it was pretty late. It was an hour and a half ish. So people were definitely ahead of me. I don't think I'm going to be on the leaderboard. But look at the private leaderboards. I know I'm still first on at least 2 of them. We'll see on CJ's. blasting ahead of these guys. Not really participating. Ooh. 13 ahead of CJ. I'm glad this is a possibility with champions. The flat alkagasm. Squished. Catching up? Oh, yeah. A little bit closer every day, I have to work a little faster. It took me half an hour just to read it. It works so far. I didn't know there was a thing.
Yeah.
So day 5.
I'm waiting for Alka. I want to see if he's going to look at my solution.
So, not quite my best. Day 2 was 1,149. It's actually pretty good. Here I go. Recently had to solve one in 10 minutes to catch up with you. Is that how it works? At 31 minutes. That was 32. Oh, rank. What is rank here? This took me 14
Wait,
minutes.
someone has a question?
This took an hour and 9.
What's the private leaderboard? I'll send a link.
Sure.
It's this.
Yeah, then rank 70,000. Well, it's actually better. I guess some people didn't realize it.
So the scores are based on time of submission. Not the execution time, but how fast you solve it after it's released. So it's released
reading and then fiddling with
at midnight Eastern time. And basically the first 100 people to solve it after it's released at midnight Eastern time make it to the main leaderboard and get a lot of extra points. Then it's based on how much time after it was released. So like Alka's looking at, I think, stats right now, like leaderboard self. Let me look at mine. Because you can see how long it doesn't say how long it took you to solve it. It says how long after it was released. Personal stats. Yeah, so you can see I solved today's 58 minutes after it was released. And day 1, I didn't start until day 2. So it just says, like, you submitted it 24 hours after, like, greater than 24 hours after it was initially released. And you can see I didn't start trying to solve it immediately after they got released until yesterday. Before that, I just randomly decided to start solving them. But now I'm trying to do it, like, right when they're released. Yeah, I don't know if I've seen the latest season of Mr. Robot, but it's a great show. Oh, yeah, let's see. Is Alka looking at my solution yet? Look at my solution!
Did I get on for day 2? I think I did. Did I stream day 2? I can't remember. Yeah, we did. So we definitely played Overwatch, and I was definitely beaten. What was that? Was that for day 3? I think it was for day 3. Anyways, everyone should definitely check out Coding Garden if you haven't. Did you take a look at my solution? Yeah, oh, right. I started getting into it. Just the differences that you've made.
Hello, everyone.
So code 99, return op. So this is parse op. Op string, so op 2 string, because it's a number. The mode 000. Op string is greater than 1, which means that there are possible changes. Yeah, you're padding it, and then you're reading it. That's the op. You're replacing the op code with a modes, and then individual modes. Your substring 0 to 3, splitting into the modes, and your second modes. We're using parse. Okay, so right here, looping all the way through the memory, and the op in the modes. So the op is always 1 digit. Take the last digit and parse it. Gotcha.
Yeah.
Op is 1, 2, 7, or 8. That's if it's 3 or if it's 4. So then it looks like you grouped it by the amount of things that it's doing. Sort of? Not really. And then you get your jumps down here. And jump is turning I. You're setting the I down here. So you're possibly adding it, otherwise you might be changing it.
Yeah. Yeah.
That's what I put down there. I tried to group by operation type. Gotcha. Left value, when it's at 0, then you get the left value, otherwise you actually have the value of that. Something like that. And location equals that. So you're getting the operation, you're doing the operation based on this mode, so you also have the 7 and 8s, and you're returning 1 or 0.
Yeah, Alka gets it.
Right, the Katas? Alright, CJ.
Yeah. Later, Alka. Cool. Time Clock says, I could never do these. I don't know how to code yet. Wouldn't have the mental capacity. It just takes time. I've been coding for over 15 years, and that's why I'm able to do this stuff. But I used to not be able to code. There was a time in my life when I did not know how to code. And it just takes time and practice. And it's not going to take you 15 years to be able to solve something like this. You could solve something like this after practicing and coding for a year. I am not a boomer. I'm a millennial. That's funny, though. Okay, I accidentally closed Code Wars. We're going to solve this directions reduction, and then I'm going to go to bed. So where were we? Code Katas? Yes, here. Directions reduction. And let's open that kata up. I think everyone that was watching earlier when I was trying to solve this is probably gone now. So we can think back through it. But basically, you are given an array of directions. And if... Oh, it's not if the directions are back-to-back, but if... two directions will essentially cancel each other out, because if I start here and I go north and then I go south, I'm back at the origin. And so we can just forget about those. If I go south and then I go east, that's not true. Hello, Ashton. And actually, I had the comments up earlier. Yeah, so Yash says use a stack. Then I can push and pop depending on the direction. Oh, you know what? What if we had 2 stacks? Yeah, what if we had 2 stacks? Go west twice from the origin. Yes, but we go east once, so those cancel each other out. And ultimately we could have just gone west, and we could have just gone west from the origin, and we end up in the same spot. So this coding problem, basically you're given a bunch of directions and you have to reduce it down to the minimum number of steps to get to the same place. Whereas this one reduces down to west. This one doesn't reduce at all because we go northwest, southeast. They don't cancel. Well, north. Oh, these don't cancel each other out because we go north, west, south, east, and we traveled in a square. Weird. North, south. Those two cancel each other out. South, east, west. Those two cancel each other out. North cancels the previous south. Oh, I am noticing a pattern. Okay, so if it's immediately followed by its opposite, then it cancels out. All right. We're going to comment out what I tried to do before. We're going to start from scratch. And I think I'm going to, so Bob says this is why recursion makes sense to me. I think I'm going to try to use a stack. So Yash mentioned using a stack because we can push into it. I'm gonna put this way down here. That goes down there. So we need to iterate over the array. So if we pop off of the stack and it's the opposite, then we leave it off and we move on to the next one. Okay, let's just call it a stack. And now we're going to iterate over the array. I just type and eventually it works. Yeah, I mean, I do that a lot too, but a lot of people like to watch this show in particular because I just describe my thought process instead of just typing. All right, I'm going to hide the drop game. Okay, let's do it. So we need to iterate over the array. And I guess we could just do a for each direction. So if the stack has a length, we should pop off and see if it's the opposite. So if stack.length, do the thing. Else, we just say stack.push. If we push, it's going to go on to the end. If we pop, it comes off of the end. Right? Yeah, so we're going to just do a push and a pop. It's not like a traditional stack. It is just a JavaScript array, but this should work. So we're going to push that direction. But if it has a length, we're going to grab the previous direction. Stack.pop. And if the previous direction is equal to opposites at that direction, we leave it off. And we don't push this on. But if it's not equal, then we need to push the previous direction back onto the stack and push the current direction onto the stack. So we'll say stack.push previous direction, stack.push direction. But if it was equal, we don't push in and we leave the previous one off because it just cancel each other out. I think this is it. We return the stack. Did I do it? Did I just solve it? We'll see. Return stack. Yep, I just solved it. Look at me. Look at me. That's too easy. Okay, I'm gonna throw this into to Code Wars to see if it actually works for many different scenarios. Too smart. I did 100 lines of code. Sample tests work. Wow. See, if you step away from a problem for an hour and a half, you'll just figure it out. But this makes a whole lot of sense. Like the way I was thinking about it before was like, if there's a north and a south, anywhere they cancel each other out, but they actually don't. They only cancel each other out if they're next to each other. And using this stack, it keeps them next to each other. So, actually, yeah, let's debug this. So I can show you what's actually happening here. I want to show you what happens with this one, which ultimately gets reduced down to west. Let's debug it. Hello, the Abby. What do you need help with? Okay, so we're going to jump into this function call. Initially, our stack starts off totally empty. And now we're going to iterate over the array of directions, which is north, south, south, east, west, northwest. Okay. So stack doesn't have a length. So we're just going to push our first value north into there. All right. Now, back around. Stack does have a length. And now we're going to pop off the thing that's in there. So we're going to pop off north, and we're going to compare that with south. So the previous direction is north, and the opposite of south is north. So because we had a north and a south, and we've already popped north off, now currently stack is empty, and we're not going to push in south because it cancels out. So we're going to skip over this, and the stack stays empty. So at this point, we are here. So next time around, the direction is going to be south. Our stack is empty, So we just push in south. This is where it gets interesting because east, so we come back around, stack has a length. The previous direction is going to be south, right? But that is not the opposite of east. The opposite of east is west. So because it's not the opposite, we push both of them back into the stack. So currently the stack is empty. We then push in the previous direction, which was south, and then we push in east. So we have southeast. Great. Now we go back around, and now we're at west. This is a conflict, right? So whenever we pop off, we're going to get east. So our previous direction is east, and that is the opposite of west. And because they're opposites, we're not going to push it back in. So now our stack only has south in it. We'll skip over this. Now we get to north, and this is where this north cancels out that south, right? Because our previous direction is south. So previous direction is south. That is the opposite of north. So we don't push it in, and now our stack is completely empty. So in terms of like walking in directions, when we get to this point right here, we're literally back at the origin. We've gone nowhere, and then we go west, and so that's the only thing that'll end up in the stack at the end. So our stack has west. Whew. Wow, we did it. We did it. You know what? I don't know if you've watched Code Wars Code Katas, like this is episode 36, but if you've watched the past episodes, every time I come across this problem, I don't want to do it because I couldn't imagine how to solve it. But we solved it fairly quickly too. Nice. Okay. And thanks for the follow, Prophet LTU. Okay, let's submit this and let's see how other people solved it. I would like to see a recursive solution. Oh, and Bob did send us his solutions. Let's take a look at Bob's solution. Bob's solution. It's very ugly, but it works. So if you go to github.com/codinggarden/code-katas, you can see all of my solutions, but these are from codewars.com. Code Wars. You end up back at the origin. You don't get why the second one isn't reduced. You do end up back at the origin, but you traveled in a square. So the fact that I'm saying you end up back at the origin, that's not what causes a reduction. A reduction is if you backtrack immediately after having done something. So like north, west, south, east, you've traveled in a square. But if I go north, south, east, west, I've canceled myself out, and I could have just stayed at the origin. I think, right? I think. All right, let's look at Bob's solution. Where is it? Here it is. Okay. This is not 100 lines of code, Bob. This is fine. Okay. I like that you broke it down into functions. So you have your directions reduced. If the length is 0, or the length is 1, done. I guess that's like your base case for recursion, right? If it contains opposites, if it doesn't contain opposites, return the array. That makes sense too, because if an array has northwest only, then you're good. So in other words, a reduction is a cyclical graph. Yes, it can have cycles. Yeah, I'm trying to think how to visualize it. And also, this is the one that I just solved. Let me provide a link to it. This, so you can take a look. You can try to solve it if you want. They have a pretty long description of it. Yeah. Okay, so it actually explains this one. Let's read this. So not all paths can be made simpler. The path northwest, southeast is not reducible. North and west, west and south, south and east are not directly opposite of each other and can't become such. Hence the result path is itself northwest, southeast. So the only time you would cancel something out is if the opposite happened right next to it, or before two opposites happen which cancel each other out. Yeah. A reduction is the matter of whether or not the path will take you back to the origin within 2 moves. But the second one you could have... Yeah, it's true. Yeah, I'm not saying it's not. I just described it wrong, but cool. Let's look at Bob's solution. So otherwise, we're going to iterate. If the two next to each other are opposite, array at I equals 0? Oh, so you're basically trying to remove it. I see. So you blank it out. Yeah, so if they're opposite, you blank both of them out. And then you filter out anything that's not a 0 and recursively call it again. That kind of does the same thing. Yeah, that kind of does what I was doing, because that would have looked at north, south, removed them. It would have looked at southeast. No, well, sorry. They're not opposite. It would have looked at east, west. Those are opposite and they're next to each other, so it would have pulled them out. And then you're left with an array that just has south, north, west. You would have compared south and north. Those are opposites. Those would have gotten removed. And then you just have an array with west. This is not at all a bad solution. Like your R opposite function, it could have been simplified by creating an object like this, but that's totally fine. What is this? Contains opposites. Hi. Cool. Yeah, this is not at all a bad solution, Bob. Great work. Great work. We can see how other people solved it too on Code Wars. North, south, east, west. South. Okay. Yeah, so they created an opposite object like I did, and then they reduced it. Whoa, someone did it with a regular expression? So they took the array of directions and combined them all together with no space in between, and tried to match north-south, south-north, east-west, or west-east, and removed any pairs that were next to each other. And they do it over and over again. So they would remove it, and then if that resulted in creating two that are next to each other after removing one, it would then remove those. it's hilarious. Wow. Yeah, and then they put it back into an array. Genius. Yeah, genius. Cool. All right. So I gotta go. I've been streaming for way too long, 3.5 hours. I think I missed a few chats. So it doesn't count cycles that are 3 or more moves. I don't know if it has to do with the number of moves. It's just if two opposite moves are not one after another. So, like, you don't have a north-south or an east-west or a west-east or a south-north next to each other. And that also takes into account even if they weren't exactly next to each other, if they were after something that canceled itself out, technically those two canceled themselves out too. I don't know. I can't explain it that well. Yeah. Yeah. If you have a problem and think, I know I can use regex to solve it, now you have 2 problems. Exactly, C# warrior. You're so right. It's so simple that the garden couldn't figure it out. Yes. Okay, I gotta go. Like I said, all this will be pushed up to GitHub. So if you go to github.com/codinggarden/code-katas, all the code from previous episodes is there. I'll push up this code. If you have suggestions for katas for me to solve, you can open an issue. There are actually quite a few open. So I do this show every Wednesday at 8:20 p.m. Mountain Time, which is 10:20 p.m. Eastern time and 6:20 p.m. Pacific time. But you can suggest katas, and I'll attempt to solve them on the next show next time. Thanks everyone for tuning in. Shout out to Alka for solving the advent of code and looking at my solution. What time is that AEDT? I don't even know what AEDT is. Australian Eastern Daylight Time. I have no idea. MDT to ADT. 8 p.m. Mountain Standard Time. Two a.m. Wait, no. I got that opposite. 8 p.m. Oh, it's 2 p.m. That's not a bad time for Australia. I usually use, yeah, World Time Buddy I think is really good. Is this the one? And thanks for the follow, I Heart Tofu. It's not loading for some reason. Oh, regardless. But before I was working on Code Wars, we actually worked on Advent of Code. So I'll share the info again. If you want to join the Coding Garden leaderboard, you can use this info. But Advent of Code is a daily code challenge that happens every day. It started December 1st. It's leading up to Christmas Day, and there are basically 2 code challenges that you do each day. And we have our private leaderboard, which you can join. And I'm in second place. Alka's in first. And Alka might still be streaming. Let's see. Oh, no, he's not.
What?
Oh, he's hosting the Cardboard Cowboy. But Alka is another live coder, and he was solving it at the same time as me. All right, let's find somebody to raid, and then we'll get out of here. And thanks for the follow, Time Clock. What do I think about Python? It's pretty cool. So I've been in the JavaScript world for like the past 5 years and mainly just doing JavaScript. But before that, I worked with researchers and I did a whole lot of Python and quite a bit of C# as well. So Python's cool. You can do a lot of cool stuff with it. I like that it's dynamic in nature, very similar to JavaScript. And a white space sensitive language is interesting to me. I definitely am accustomed to programming in like C style, which is JavaScript with like curly braces and semicolons and stuff like that, but white space is a nice breath of fresh air. Heretic is asking, how much JavaScript should I learn to be able to solve bugs on a P5 library in the P5.js browser? It really depends. You can take a look at the P5.js GitHub. Maybe it's just that? Yeah. Take a look at issues. And usually they have their issues marked as like good for beginners. So let's see. Yeah, they have like level beginner. So you could go into issues. They didn't have anything marked as beginner. We could try level intermediate or moderate. Yep, there's nothing there. Usually projects like this will have some sort of label that will help you determine if it's going to be hard or easier for you to let's just find all the bugs. There's not that many actually. So it's hard to say. Typically what I like to do is just try. Just go for it, like find a bug and try to figure out what's happening and see how far you can get. And you might find your deficiencies. Like you might find where you have no idea what's happening, and that's the kind of thing that you need to work on. Yeah, r/that happened. I guess we could raid Codephobia. We've raided him before. He's usually working on Angular. Let's see who else is in science and technology. That's me. Right there. Oh, Anthony is doing Advent of Code in Rust. That's cool. Advent of code in Python. Let's see all the people that are doing Advent of code. Rust is an interesting language. Yeah, so Brooke Zerker is a Twitch streamer. He's been on my show before, but oh, he's hosting me. Look at that. But he streams himself most mornings doing Nature of Code with GG Easy and Rust, which is pretty interesting. There's Space Boy. Anthony writes code. Actually, where did I see Anthony writes code? Oh, he was in Alka's chat last night.
Position 0. Okay, what that is.
Let's see what language they're using.
Take another position 0.
They're using Python.
Let's take position 1.
Space Boy is on a break. Anthony writes code. Are they using Rust? Yeah, we're gonna raid Anthony writes code. Late night stream. Yeah, I gotta go though. I have to. Oh, it's already midnight. Oh man. I can't stay up this late. But we are going to we're gonna raid Anthony writes code. But if you're watching on YouTube, head over to twitch.tv/codinggarden. You can join us in this raid. Head over to twitch.tv/. But a raid is where we take all the viewers of one live stream and send them to another live stream. So we can watch Anthony writes code, solving Advent of code with Rust. See you later, Morning Sage. Thanks for tuning in. But this is our raid message. So when we go into his channel, we're gonna send lots of love. We're gonna send some Coding Garden seedlings and the Coding Garden heart. So copy and paste that message. Oh, not that. But copy and paste this message. This is what we're going to send. Oh, yeah, I'll enable the drop game for like the last few seconds. That's the message we're going to send when we do the raid. Are you ready? I'm ready. I need to go to bed. It's way too late. It is way too late. Alrighty, everyone. Wherever you are in the world, have a wonderful morning, afternoon, evening, or night. And until next time, here's this.